Hello, this is Hemant Kumar Nayak, and I want to practice my English. And I am preparing for heat transfer interview question and answer. So I am starting. So first question is when to use double pipe heat exchanger and cell and tube heat exchanger. So we have two types of heat exchanger. First is double pipe heat exchanger and another one is cell and tube heat exchanger. So, double pipe heat exchangers are used when the heat transfer area is small, say up to 14 meter square. And so if we heat transfer area is small, we can use double pipe heat exchanger. And if we connect them in series to increase the heat transfer area, it will require much space as well the pressure drop will be higher due to more fittings. Also, we can't increase the number of passes for either side of fluids. The double pipe heat exchanger can be used for dirty fluids due to choking and cleaning is tougher. The advantages is it is simple to construct and easy to operate. But in cell and tube heat exchanger, we can take a large heat transfer area within a small volume. As the numbers of tubes are more in cell and tube heat exchanger, we can expect higher turbulence which will result in higher heat transfer rates. Dirty fluids also can be handled owing to easy cleaning. So for the small heat transfer area, uh, about 14 meter square, we use double pipe heat exchanger, and for high large heat transfer area, we use cell and tube heat exchanger. In case of cell and tube heat exchanger, we have more number of tubes, so dirty fluids can be handled. And next question is what is Biot number? So Biot number is dimensionless number defined as Biot number is equal to HL by K, and here H represents convective transfer coefficient and L represents characteristic length and K is the thermal conductivity of body. It is the ratio between conductive heat transfer within a body to that of convective heat transfer away from the body. If it is above 1 means convection is more and less than 1 means conduction is more. Biot number is basically HL by K, and here L is characteristic length, and we can find that if you know volume of the body and surface area of the body, so it is the ratio between conductive heat transfer within a body to that of convective heat transfer. So it is a ratio of conductive heat transfer by convective heat transfer. And if it is greater than 1, then it is convection, and if it is less than 1 means conduction is more. The next question is what should be the pressure to be taken for pipe and reactor before put in service? What should be the pressure to be taken for pipe and reactor before put in service? For pipes, the test pressure should be double the proposed application pressure, and for reactors, test pressure should be 1.5 times the reaction pressure. It means if you used to subject a pipe to 10 bar, we have to do pressure testing at 20 bar, whereas for the reactor it will be 15 bar. So question is what should be the pressure to be taken for pipe and reactor before put in service? Yeah, so basically we want to know about how much pressure is to be taken. For pipe, the test pressure should be double the proposed application pressure, and for reactors, test pressure should be 1.5 times the reaction pressure. It means if you used to subject a pipe to 10 bar, we have to do pressure testing at 20 bar, whereas for the reactor it will be 15 bar. Okay, okay, so this is the condition. And next question is which liquid should be on cell side of a cell and a tube heat exchanger and why? So we have cell and tube exchanger, and then we have cell and we have tubes. So we want to know which liquid should be on cell side. So for that uh, answer is even though there are no strict condition on this, the following points are taken into consideration normally. First is the corrosive fluid cell pass through the tube side. So the corrosive fluid which can corrode uh, the cell. That's why we use corrosive fluid in tube side. And the replacement of tubes is easier and cheaper than cell side. Okay, so because replacement of tube is easier. And next thing is the toxic hazardous fluid cell pass through tube side. And whatever liquid is toxic or hazardous, then we can pass it into tube side. Because in case of any leakage, it won't get exposed to atmosphere. So this is the reason which liquid should be on cell side first cell into will change. So corrosive and toxic and hazardous fluids say pass through tubes and we cannot pass it into cell side because it can corrode or uh, and sometimes it will expose to atmosphere. The next question is how we can find leakage in any tube and cell and tube heat exchanger. So we want to know leakage in any tube and cell heat exchanger, cell and tube heat exchanger. So leakage in tube. We have to remove the bonnets of left and right side of the heat exchanger. We we have to force liquid through the cell side with high pressure. It will penetrate the leaked tube and come out via the same tube. Thus, we can find the leakage. Okay, so we have to remove the bonnets of left and right side of the heat exchanger. We have to pour the liquid into the cell side with high pressure. High pressure, we have to apply high pressure, and then it will when it will penetrate the leaked tube and come out via the same tube. What is the difference between vapor and the gas? So a vapor is formally by heating any liquid and it can be condensed at atmospheric condition either by reducing temperature or increasing pressure. But a gas has already above the critical temperature and can be condensed by application of above method. So gas is already above the critical temperature and can be condensed by application of above method. First, it has to be brought below critical temperature, then only it can be condensed. Vapor is from heating any liquid and it can be condensed at atmospheric condition. And gas is above critical temperature and can be condensed by application above method. Okay, so vapor we can easily can generate by heating the liquids, and gas is is means above critical temperature, and we cannot condense that. That's why we call it gas. And so next question is why the hot liquid in heat exchanger reactor jacket should flow from bottom to top. Why the hot liquid in heat exchanger reactor jacket should flow from bottom to top. If we pass the liquid from top to bottom, it will flow fast by gravity itself, so it will have less contact time with the heat exchanger or reactor surface, which will result in poor heat transfer. So that's why the hot fluid should be passed from bottom to top to maximize the contacts. Okay. Maximum contact is possible if you pass from bottom to top. The same is applicable for cold feed also in reactors. Next question is why steam enters top side of liquid in reactor? Why steam enters top side of liquid in reactor? If you pass the steam from bottom side, the condensate that is formed after losing the heat won't have a comfortable passage to get out of the system. In turn, the entering steam will start to hit the returning condensate rather than hitting the reactor surface. That's why we have to pass it from the top. Okay, so next question is when we need pumps in parallel and pumps in series. Uh, we need a higher discharge flow Q. We have to go for pumps in parallel arrangement. In a higher discharge flow, we have to go pumps in parallel arrangement. If you need a higher head, we need to go for pumps in series. We higher head, then pumps in series is there, and for higher discharge, we have to go pumps in parallel arrangement. So pumps in parallel series. When to use gear pumps? When we need to handle high viscous liquid, we need gear pumps as they deliver high discharge pressure, even up to 200 bars. Which give me comparison between orifice meter and venturi meter. It is important. So the orifice plate can easily be changed to accommodate widely different flow rates, whereas the throat diameter of venturi is fixed so that its range of flow rates is circumscribed by the practical limits of DP. So we cannot change throat diameter as it is fixed, and we can change orifice plate. So this is the difference. The orifice meter has a large permanent loss of pressure. So in orifice meter, we have large pressure drop, and because of the presence of eddies on the downstream side of the display, the shape of the venturimeter prevents the formation of these eddies and greatly reduces permanent loss. So in case of orifice meter, we have more pressure loss, and in case of venturimeter, we can less pressure drop. The orifice is cheap and easy to install. The geometer is experiencing as it is must be carefully proposed and fabricated. And this is the thing. And why centrifugal pump are widely used in process industry than positive displacement pump. We have centrifugal pump and we have positive displacement pumps. Centrifugal pumps are widely used in process industries because they are simple to construct and operate. Installation and maintenance are easy. Casing can be made of a variety of materials. None. Noise-free operation, no need of safety valve at discharge side in case of single stage centrifugal pumps. Can handle can handle variety of liquid. The impeller MOC can be filtered accordingly. You brief classification of handling pumps. What is surging in compressor and how it can be prevented. Differentiate compressor, fan and blower. Fans, blower, and compressors are differentiated based on the method used to move the air and a specific ratio. Specific ratio is defined as discharge pressure by suction pressure. As per the American Society of Mechanical Engineers (ASME), the compression ratio for fans is up to 1.11, lower 1.11 to 1.2, and for compressor above 1.2. What is difference between Job and Hajan? Job and Hajan, it's thing, why we use LMTD to calculate overall heat transfer coefficient in cell and tube then arithmetic average. In a heat exchanger, the heat being lost by the hot fluid as well as the heat gained by the cold fluid is not linear. So we need to use logarithmic average rather than arithmetic average to calculate correct value of overall heat transfer coefficient. Yeah, so in heat exchanger, the heat being lost by the hot fluid as well as the heat gained by the cold fluid is not linear. That's the reason we use logarithmic mean temperature difference. So what should be the packing size in packed column? The size of packing should be approximately 1 by 8 of the internal diameter of packed column for optimum pressure drop. 1 by 8 of the internal diameter. When to use absorption factor method to calculate number of plates? We have to calculate the number of plates. For that, if the operating data line and equilibrium line in the McCabe-Thiele method runs parallel to the number of the plates, would be infinite, so it would be impossible to find the number of plates as the both won't touch at any point. So we need absorption factor method, wherein a number of theoretical plates can be found by Fenske equation. So how to convert ppm to percentage? We have divided by 10 to the 4 to the ppm to get converted to percentage. To convert percentage to ppm, we have to multiply by 10 to the power 4. Calculate parts per million. What is the threshold limit value? The threshold limit value was set by the conference of the engineers, which is defined as the level of concentration of chemical substance in which a worker can work without an unreasonable risk. So, obviously, injury, it can be expressed in ppm or milligram per meter. For example, the threshold limit value of chlorine for 8 hour work day is 0.5 ppm or 1.5 milligram per meter cube, which indicates a worker can work without any unreasonable risk. What is critical insulation thickness for pipes? We know that by adding more insulation to a wall always decrease heat transfer. The thicker the insulation, the lower the heat transfer rate. This is expected since the heat transfer area is constant. And adding insulation always increase the thermal resistance of the wall without affecting the convection resistance. Adding insulation to a cylindrical piece or a spherical shape, however, is a different matter. The additional insulation increases the conduction resistance of the insulation layer but decreases the convection resistance of the surface because of the increase in the outer surface area for convection. The heat transfer from the pipe may increase or decrease depending on which effect dominates. Consider a cylindrical pipe of outer radius or huge outer surface. So for cylinder, it is come up to K by H. What is priming in centrifugal pump? Priming is a technique used to drive away the air entrapped in the suction line of a centrifugal pump. If the air present in the suction line are not removed, the pump won't be able to suck the liquid from the reservoir. As air is a lighter medium, whereas liquid is higher medium. So the whole suction line and the part of casing is filled with water and the air is moved via the air vent. Also, if air is allowed to enter to the impeller, they will damage the impeller by flashing. What is the difference between flow PFD and PID? PFD process flow diagram gives us picture about stages of the process, but the PID process instrumentation diagram shows us the location of valve, pumps, compressor, utility DC in the process. What is MOC heat exchanger? Material construction of heat exchanger depends upon the properties of the liquid or vapor being handled, pressure and the temperature condition. Normally, it can or carbon steel, stainless steel, nickel alloys, or other special alloys. Wire thinker injector. The ground the static electricity that may be produced in the reactor due to reaction. YSS are not corrosive. The stainless steel contains some percentage of chromium. The chromium reacts with oxygen which is present in air to form CO2, which prevent further oxygen to react with iron. This is from when distillation is needed. In case if the substance being distilled may degrade before it reaches its boiling point, we have to boil at a lower temperature than when liquid distillation is needed. In case if the substance being distilled may degrade before it reaches its boiling point, we have to boil it at lower temperature than its boiling temperature. That's why we need vacuum distillation. What is the use of plate efficiency in distillation column? Plate efficiency in plate column is used to convert the threshold number of plates into actual number of plates. As any plate can perform ideal, we have to multiply its efficiency with theoretical number of plates to get actual plates required. When extended surface heat is required, when the temperature difference between two fluids is less to achieve higher heat transfer rate, we may have to increase the external surface area. That's why we need extended surface heat exchanger. How liquid nitrogen is saved in tanks. Nitrogen is available in liquid form after compression. It is exposed to atmosphere directly or comes in contact with heat to do less effort. So we need to protect the nitrogen storage from the outside temperature. The boiling point of nitrogen is minus 195.8 Celsius. To achieve that, it is stored in inside vessel within outer vessel surrounding it. In which type of condensation, film type or dropwise heat transfer would be higher. In dropwise condensation, the drops form will fall and then the new steam in that enter will find a new surface to contact and to transfer it. But in film type condensation, a film will be formed on the tube which will prevent the fresh steam to contact the tube surface. So naturally, dropwise heat transfer will be higher. Dropwise heat transfer will be higher because drop form and fall and then the new steam that enter will find a new surface to contact. That's the reason dropwise heat transfer will be more. What is the use of baffles in heat exchanger? Baffles installed in heat exchanger act as an obstruction in the flow path of cell side fluid. It reduces the effective cross section area to which the liquid travels. Due to this, the velocity and turbulence of liquid is increased, thus resulting in high heat transfer. Why baffles are used in reactor? The purpose of baffle in reactor is same as that of heat exchanger. Here also, they increase turbulence, thus causing high rate of heat transfer, mixing thus ultimately reaction rate. What are the color code for cylinder of oxygen, carbon dioxide, and chlorine? Oxygen is white, carbon dioxide is gray, and chlorine is yellow. For more details, what is the difference between falling and scaling? Falling is caused by the collection of loose debris over pump suction spring in sumps or growth of algae in some areas where scaling is dissolvement on equipment surfaces. What is your dry bulb temperature? Wet bulb temperature. Dry bulb is the temperature of ambient air measured by thermometer. It is called dry bulb temperature because the temperature shown by thermometer is not affected by the moisture content of the air. The wet bulb temperature is the temperature of adiabatic saturation. This is the temperature indicated by moist and thermometer bulb exposed to the airflow. Wet bulb temperature can be measured by using thermometer with the bulb wrapped in wet muslin. The adiabatic evaporation of water from the thermometer and the cooling effect is indicated by wet bulb temperature lower than the dry bulb temperature in the air. What is the dew point and why it is important in instrument? The dew point is the temperature at which water vapor start to condense out of the air. The dew point is the temperature at which water vapor start to condense out of the vapor. The temperature at which air becomes completely saturated. The temperature at which air becomes completely saturated. Above this temperature, the moisture will stay in the air. Above this temperature, the moisture will stay in the air. I'm stopping here. And let's pick another topic.